For the problem 2, we are given that x is uniformly distributed from A to B. So we have the probability density function of x, fx equals to 1 divided b minus a, where x is from A to B, and the density function equals to 0 otherwise. And we can draw this probability density function as follows. And this line is 1 divided b minus a, and this is for the probability density function of x. And to calculate the distribution function of x, it is the integral of probability density function from minus infinity to x, and it is equals to 0 when x is smaller than a, and it is equals to x minus a divided by b minus a when a is from where x is from A to B, and it equals to 1 when x is greater than b. And based on this formula, we can draw the distribution function of x. It is 0 when x is smaller than a, and it is linear when x is from A to B, and it equals to 1 when x is equals to b. And this is for the part A. To calculate the probability density function and the probability distribution function. And for the part B, now we are given that A is equals to minus 1, B is equals to 3. So we can write the probability density function by plugging the value of A and B. It is equals to 1/4 when x is from when x is from minus 1 to 3, and it is 0 otherwise. And we can also plug in the value of A and B to get the distribution function of x, and it equals to 0 when x is smaller than minus 1, and it equals to x plus 1 divided 4 when x is from minus 1 to 3, and it equals to 1 when x is greater than or equal to 3. And now we are given that y equals to x to the power of 2. We need to calculate the probability density function of y and the distribution function of y. And as we can see here, there are 3 cases, there are 3 segments of probability distribution function of x, which is these 3. So, and we have y equals to x to the power of 2. And so we should also divide y into 3 segments. The first one, the first one is and we need to calculate the probability distribution function of y, which is fy equals to the probability of y smaller than y, and by plug in of y equals to x to the power of 2, we got it equals to probability of x between the square root of y, a minus square root of y, and positive square root of y, and it is equals to the value of square root of y minus the probability distribution value of the minus square root of y. So as we can see that the probability density function of x is divided into 3 segments. So we have to divide the square root of y into 3 segments also. The first segment is the square root of y greater than 3, and so the minus square root of y is smaller than minus 3, and y is greater than 9. In this case, we have the probability distribution function of y is equals to y minus 0 equals to 1. And second segment is the square root of y is between 1 and 3. And in this case, the minus square root of y is between minus 3 and 1, and y is between 1 to 9. And in this case, the probability distribution function of y is equals to square root of y plus 1 divided by 4 minus 0. And for the third segment is the square of root of y is between 0 to 1. And we have y is between 0 to 1 also. And the minus square root of y is between 0 and minus 1 also. So here we have the probability distribution function of y equals to square root of y minus 1 plus y divided by 4 minus the minus square root of 1 plus 1 divided by 4. This is the subtraction of these two functions. I did these two formula and we got the square root of y divided by 2. So we have these 3 cases, and we need to I need to get this part smaller. And so here, based on the left, we have got that fy, which is the probability of distribution function of y, is equals to this 3 segment. Is equals to this 3 segment, and then we need to calculate the probability density function, which we just need to take the derivative of big capital Fy. And we got it equals to 1 divided by 4 times square root of y when y is from 0 to 1, and 1 divided by 8 times the square root of y when y is from 1 to 9, and 0 when y is greater than 9. And this is the probability density function of y. And so we have calculate these two, and we then need to plot it and so we just plot by the formula, based on the formula. This is for the probability distribution function of y, and it is equal to 1, 1. It is greater than 9. And this is the probability density of y. It equals to 0 when y is greater than 9. And this is for the two plot. And finally, we need to calculate the expected value of y. The expected value of y equals to the integral of y times the probability density function of y from 0 to infinity, and we just need to plug in the formula as we derived above, which is equals to integral of square root of y divided by 4 from 0 to 1, and the integral of square root of y divided by 8 from 1 to 9, and then we get the value of 7 divided by 3. So this is the expected value of y.